All right, welcome everybody. My name is Brian McLogan, and I am going to work through a homework assignment today for this live stream on parametric equations. So today in my class, we kind of worked on, we learned about parametric equations, where they came from, why they are helpful based on kind of like a word problem that we investigated for a long time, and then we worked on eliminating the parameter. And some of these problems are actually the same types of problems that we kind of looked at as a class. So we're going to look at eliminating the parameter here, and then we have a nice little word problem that we'll get to. And then the multiple choice actually are all just eliminating the parameter as well. So it's just going to, hopefully should be kind of quick, kind of straightforward. Obviously I want students to, be familiar with eliminating the parameter as the process, really kind of the main thing. But it's also going to be helpful for them to understand, using how we can use parametric equations, for instance, like on this word problem, to be able to better understand, what is actually happening, on a particle motion problem with respect to time. So, anyways, that's basically what I'll do. Is hopefully I shouldn't take too long on this. So if there are some questions that I'll be able to answer with you guys, I'll be more than happy to help you out with that. I do see here, well, Josh, seriously, my life as Maddie, Trusty, Andy, Kaif, Finistan, and Trusty, see you guys all here. That is very awesome. I am Indian. Sweet. Who's on? Yo, what's up? Mr. Clean, yes. I actually, it's kind of funny. I'm not sure if I've seen him, but I actually went as Mr. Clean for many, many years, especially when I was in college. It was very easy, very cheap to do. I just buy a white shirt and I would get a gold earring, and let's see what else I had to paint my eyebrows white, and then I'd shave my head, and then I was Mr. Clean. So, and obviously in college when you're, kind of funds are low, you're trying to just, have a new costume, have something that's simple as a costume. Mr. Clean was a great costume, but I haven't brought it back in a while, so maybe that's something I could be thinking about. All right, so what I'll do, guys, is I'll just kind of run through that. I'm glad you guys are here, and again, if you guys have any questions as I'm working through these problems, feel free to go in the chat. I will take a break here from the free response to the multiple choice, and therefore, if there's any questions or anything you guys want me to elaborate on, I'll be more than happy to do that for. And then otherwise, I'll just get into this multiple choice. And then we'll answer some maybe questions at the end. So, all right, eliminate the parameter and then determine the graph of the curve. So what I told my students, typically what we want to do eliminating the parameter is solve for t with the x equation. That's not always the case, but typically that's what we're going to want to do to kind of understand the graph of the curve. So in this example, that is, no exceptions here. That's exactly what we're going to want to do. So now typically you'll kind of see when it's obvious, when it's not easy to solve for t in the equation with the x, then that's when you'd want to solve it for y. But again, in my class, we haven't really talked too much about equations that are set equal to x, so therefore it'd be kind of mean and unfair of me to give them a whole bunch of those types of equations. But it is something possible. We did talk about like sideways parabolas, so they can kind of understand that a little bit. Since we'll be getting into analytic trigonometry next class period, it's kind of helped them out. Our analytic geometry next class period. All right, so in this case, though, I could solve for t in either equation. However, I basically understand the equation in terms of y, so I'm going to solve for t here. So I'm just going to say x equals 3 minus 2t. Subtract a 3 on both sides. Get x minus 3 equals negative 2t. And then divide by negative 2. Now, you can write it like this if you want to, but typically so even though this is fine, like x minus 3 divided by negative 2, typically we want you to, simplify this to understand, like to get it in like a simplified form. So now so typically what I like to do is go ahead and just rewrite this as a negative 1/2. So instead of dividing by 2, that's the same thing as multiplying by negative 1/2. X minus 3. Okay, so the importance on this one is, in this equation, is basically we understand we have the value of t. So what we can do is just like substitution of equations. If you guys remember, we're doing substitutions of two linear equations, you can plug one variable into the other. We now know what t equals. Now we want y to equal something, or we have y equals, and now we know the equation for t. So I can just write y is equal to, actually let's do a different equation. Let's put that as purple. That would be great. Then you guys can see a little y is equal to 2 plus 3, and then times the purple. So negative 1/2 times x minus 3. Now what's nice about this, as it's written there, I only need to multiply this times that. Since these are all separated by multiplication, you're not doing distributive property. That's really expressions multiplied by each other. So let's just simplify this a little bit more. So we get 2 plus, and that'd be a negative 3/2 times x minus 3. Okay, now hopefully at this point you can see that the power of the variable is going to be 1, so therefore this would be a line. So I'm just going to write this. That is the graph of the curve. Let's go ahead and distribute this. I'm not sure if I made up these numbers or it's just some numbers that are just not going to be nice to kind of work with. So that would be a positive, oops, that's an x. So negative 3/2 x plus 9/2. All right, so now we basically need to kind of rewrite this. I can rewrite this 2 as going to be 4 over 2. So I can rewrite this as y equals negative 3/2 x plus 9/2 plus 4 over 2. So again, the 4 over 2 is representing the 2. And therefore, I'll do this one more time. Y is equal to, and I don't know why I write all those extra equations. So let's do this one more time. So therefore, y is equal to a negative 3/2 x plus 13/2. Now you could factor out the 1/2 one more time, but I think this is an equation. This is in slope-intercept form. It's easy to understand. You can see that that is your equation. And I don't know why I decided to, why don't we just rewrite that equation like regular, like normal people. Not slanted. So y is equal to a negative 3/2 x plus 13/2. Okay, that is your final equation. Most of the other problems should not take as much time or as work. Like for instance, this one's really easy. Like x is equal to, or t is equal to x. So therefore, if I want to write this equation, I can just say, y is equal to, x squared minus 4. Well, obviously that is going to be a parabola, and that is going to be a parabola that opens up. So we looked at some different types of parametric, or we just looked at some different types of parabolas, opening up, down, left, and right. So therefore we can see, since it's x squared, we know it opens up or down, and since it's a positive, a is positive, it's going to open up. I didn't ask you to do the transformations, or to further clarify, I just said the graph, but, just trying to go a little that extra step. All right, so on the next one, again, we're just getting practice here was solving for t. Once you solve for t, then you can plug it into the next equation. Now, this is one actually I did for half of my classes, so half of them should be very familiar as long as they were paying attention and wrote down the notes. If not, then it's a new one for them. So we have x equals t minus 1, and the reason, so I add 1, so therefore I have x plus 1 is equal to t. And I think I actually meant to do this as a plus 1, but that's okay. All right. Yeah, that's what I did in the other class. I changed that. So again, in this case, what we'll have here is now we understand t is equal to x plus 1. So now I can just rewrite that as y is equal to x plus 1 all over x plus 1 minus 1, which just gives us y is equal to x plus 1 over x, which can be simplified into 1 plus 1 over x, which we notice there, that is a reciprocal function. That is going to be, that is the reciprocal function, which I allowed my students to kind of describe that as, but really what that technically gives us is a hyperbola. So the reciprocal function is not really a description of the graph of the curve. It's actually a hyperbola. But, if they at least could tell me it's a reciprocal, that's pretty good. I'd say, all right, well, at least, because we haven't talked about hyperbolas yet in this class. So I was happy with that. But yeah, that's basically plugging that in and then distributing and simplifying that a little bit further. All right, the next one, I have x equals the square root of t. So again, on this one, so like all solving for t is everything kind of been the same. Like here we had to, subtract and then divide. Here it was the same. It was really easy. Here I only had to add. So again, on this one, it's like, what do I need to do here? Well, I got to undo the square root. So to undo the square root, let's go back to purple. So to undo the square root, I'm just going to square both sides. So therefore I get x squared is equal to t. Okay? So now, basically, wherever I see t, I can plug in an x squared. So in this case, I get y equals 1 minus x squared. And then here, again, we recognize this is going to be a parabola, but it's a little bit different than this parabola because now my a is negative. So you can see that the graph is going to be opening down. Okay, you could also see that the transformation here is shifting 1 unit up. This transformation would have been shifting down 4 units. This one would have been shifting 1 unit up as well. I didn't talk about transformations, but you know, just a little add in there, add in a little extra. So the next two problems, you notice there's cosines and sines. We didn't have any sines and cosines before, right? So it's like, well, what do we do? Should we follow the same process? Well, this would be one where we're not going to want to follow the same process. And again, the whole idea, guys, is to eliminate the parameter. The parameter can be represented as a variable t, typically, or you know, sometimes theta as well. But it's like the third, it's like that extra variable. So you could, if you, especially like with a calculator, you could use your inverse operations to solve for t and then plug it into their equation. That's fine. However, we don't really understand like what that graph, what that curve looks like. Most students would not. Most students don't even know what the graph looks like right now, right? So, but what we can do is just use the Pythagorean identity. So cosine squared of, any variable, t, theta, whatever, plus sine squared of t is equal to 1. Now, again, it's just very important to understand that that is the same thing as cosine of t squared plus sine of t squared equals 1. So therefore, if we can solve for cosine of t and sine of t, we can plug them in. So let's go ahead and do that. So we have, to solve for cosine of t, I would just need to divide by 4 on both sides. And that gives me x over 4. To solve for sine of t, I'm going to divide by 4 again, and that gives me y divided by 4. Okay, so now, basically, I'm just going to plug these values in for cosine of t. So I'm going to replace cosine of t with x over 4. I'm going to replace sine of t with y over 4. Okay, and now I can just simplify this to give me x squared over 16 plus y squared over 16 is equal to 1. You might not recognize what that shape of the graph is, but if you multiply by 16 times everything, you get x squared plus y squared is equal to 16. Many students forgot this, but if you remember, guys, this is the equation for a circle. So the equation of the circle is x squared plus y squared equals r squared, or also famously known with x minus h squared plus y minus k squared is equal to r squared. Something that we are going to be working on next chapter as well. So anyways, we could say that this is a circle with a radius of 4 and the center at the origin. Last one here is x equals 2 cosine of theta, 3 sine of theta. Let's go ahead and do the same thing, really. Go ahead and solve for cosine of t. So we can say cosine of t is going to be x over 2. And sine of t is going to equal y over 3. All right. Now, basically, again, plugging them into this formula here, or into the Pythagorean identity, I would get x over 2 squared plus y over 3 squared equals 1. So therefore, this gives me x squared over 4 plus y squared over 9 equals 1. Now in this case, we can't just like multiply by, one number that gets rid of both my denominators. What we notice here is like the x and the y are multiplied by, or really divided by, they're divided by different numbers, but really multiplied by different numbers. So what that's going to do is that's going to affect the shape. Like you obviously notice here in the circle, like the x and the y coordinates, like remember coordinates make up the whole circle, right? They're both being multiplied or divided, right? Divided by 16, multiplied by 1/16, by the same number. So they're being impacted the same. That's why a circle has that particular, circle. All the points are equidistant from the center. Here, they're not being, they have different scalars with them. Like x is being multiplied by 1/4, y squared is being multiplied by 1/9. So you can see they're being impacted. So what that's going to do is that's going to produce, a lot of students call it an oval, but mathematically we call that an ellipse. Okay, and just a little FYI, which we'll be covering next chapter, that is an ellipse with a vertical axis. I'll just use that. It's really a vertical major axis, but I'll just kind of go from there. And I forgot to mention this. I forgot to write this one down. This is a circle as well. Okay, so this produces an ellipse because it's not equal. That's a circle. We did a parabola there, reciprocal. Cool. All right. So that's the basic of eliminating the parameter. I did a whole bunch of examples also in class. A lot of them are very similar to this, so hopefully students are kind of familiar with that. Now let's kind of get into the word problem, and then I'll go ahead and take a break if you guys have any questions. Swimshire gang or McGlow gang? I don't know. It's kind of crazy. So let's go and take a look at this. So one of the things we looked at in class today on the word problem was like the benefit of understanding parametric equations. And we looked at particle motion, and I told my students you're not going to need to memorize these equations, but if you have something that is in motion there, we basically can write them in terms of our x and our y components. So we could say x is going to equal v sub 0 times t, and y equals negative 16 t squared plus v sub 0 t plus h of 0. Okay, and what this represents is actually a ball like in motion, like being with gravity. So negative 16 is going to be referring to gravity. This is for feet per second. So therefore, whenever we're dealing with something time in seconds and we're dealing with the measurement in feet, we can use these equations. Now, this is the equation we used today, and we didn't really get to the opportunity to do a problem like this. So therefore, that's why it's a good one to kind of cover, make sure we cover in our homework. Because in this one, you notice that, well, for instance, just like let's look at the path of a ball. Like when you look at the path of the ball, right, you notice that there is this x component, right, and this y component. So basically, the parametric equations, what's helpful about them is not only do they tell us the x and the y component, but they tell us the x and y component with respect to time. Whereas in Algebra 2, what we looked at is just understanding something with a x-axis and y-axis. There was no relationship with time. It was just x is related to y, right? So that's why the parametric functions are so helpful, because they can help us understand x and y components with respect to time. And that's what we're going to do to be able to solve this question, which basically says, a ball is shot out of a cannon with an initial speed of 180 feet per second at an angle 22.5. With the horizontal, will the ball clear a 20-foot wall that is 420 feet away? Now, this equation is not really going to help us because it has no way for us to input 22.5 degrees. So the second set of equations that I told my students that were on the board was this one, where the v sub 0 is going to be basically v sub 0 times the cosine of theta t. So now we're taking this, we're taking the initial velocity, which I forgot. I said it was in their notes, but v sub 0 represents initial velocity. H of 0 represents initial height, which in this problem is 0. So that's going to be v sub 0 times cosine of theta, and then this one would be y equals negative 16 t squared plus v sub 0 times the sine of theta t plus h of 0. Okay, so let's go and look at what we have here. We have 180 feet per second, so that is going to be our v sub 0. We have a degree, an angle. We're just going to call this theta. All right. Now we'll come back to this one in a second. But based on this information, can we go ahead? Actually, let me do these in green. Okay. So let's make this our v sub 0, and let's make this our theta. All right. So right now we know that's your initial speed. It even says initial speed, right? And then this is our angle, right? Because you can see it's in degrees. Will the ball clear things? So let's just go ahead and write up our equation. So I can have x is going to equal 180 and then cosine of 22.5 degrees t. And then y is going to equal negative 16 t squared plus 180 times the sine of 22.5 degrees t And then obviously h of 0 is equal to 0, so I'm not going to worry about it. So those are my two equations. Now, I told students you don't need to have a graphing calculator. And actually, I keep on forgetting to bring my graphing calculator home, so I can't even do this problem with the graphing calculator. So I am going to do this problem with a TI-30X. However, I do want you guys to see the graphical approach, so I will show up my Desmos after I do this without the calculator, or without a graphing calculator. So the first thing is, basically, here is the path of the ball. So this is just the general understanding of a parametric equation. But obviously, we know that this ball is going somewhere, like this, right? We don't know when it's going to land or whatever else. So will the ball clear a 20-foot wall that is 400 feet away? So basically, let's figure out how far the ball is. Like, where is 400 feet? So, we know the ball is going in that direction, but at like 400 feet, so here's my first question. At 400 feet, what is the time? Like, what is the time at 400 feet? Because again, x represents how far the ball is traveling horizontally with respect to time, whereas y tells you the height of the ball with respect to time. So if I can figure out how long it takes for the ball to travel 400 feet, I can take that time and then plug it into y. So first part I'm going to do is I'm just going to take 400 and set that equal to x, and that's going to be 180 times the cosine of 22.5 t. So basically t is equal to 400 divided by 180 cosine of 22.5. So that's exactly what I'm going to type into my calculator. So I'm going to do, I like to type in 180 times the cosine of 22.5. And then I do, and then I do 400 divided by that last answer. And I'm getting t is equal to 2.4. T is equal to 2.4. Now, however, that is the rounded answer to the nearest tenth. I don't want to use a rounded answer, so I'm going to store that as alpha a. Okay, so I can store it at least in this calculator. Now, what I'm going to do is I'm going to plug that value into this y equation to figure out the height, right? And if the height at 2.4 seconds is higher than 20 feet, then I know it cleared the wall. If it's less than 20 feet, then I know it will not have cleared the wall. So now I'm just going to type in y is equal to negative 16. Now again, I am using a as my value here. So I'm not going to use 2.4. I'm just going to use the a stored value squared plus 180 times the sine of 22.5 times a. So it's a lot to type in your calculator, but let's go and see. Oh, no. That's negative 6. Yeah, that works. Okay. All right, so it's stored. Let's see what we get here. So negative 16 a squared plus 180. Now we got to be careful with the parentheses. Sine of 22.5 times a. And I get 73.6. Or 73.1, I'm sorry. So what that means is so again, let's recap. Here are your two equations based on the information we've given as well as the formulas we have. I need to figure out, it's asking us, will the ball clear 20 foot at 420 feet away? And I was using 400. Well, crap. Why did I do that to myself? I got to redo everything. I could just change the number, and that'd be the easy way out. Actually, you know what? I'm just going to change the number. That's the easy thing to do. Because guess what? Even when it's 420 feet away, the answer still doesn't work. So no worry. So it's going to be the same answer anyways. And let me show that to you. Let's prove that. So what I'm going to do is I'm going to get rid of my full screen here. I am going to bring over my Desmos, and I'm going to show you guys that equation. So again, it's 180, 22.5 t plus 3. All right, so I am going to switch over to this. There you go. Now you guys can see my Desmo screen. Now, come on. No. Are you serious? Stop. It's like it's... I had it all... Why did you save? It's not allowing me to like readjust the size that I had. Come on. That is not very nice. No, I can't work with this. Come on. All right, you know what? I'm just going to go back. Try this again. All right, so going into Desmos. I have a lot of equations. Let's see if I can find mine. 6F, parametric equations. Okay, well, there's the equation. So basically when doing parametric equations, basically what you do is you kind of create it as a point. So you can see here that I have the x equation here. Instead of it saying, x equals, that's basically like my x coordinate. So if you remember from our sheet, that was 180 cosine of 22.5t. And then I have the y coordinate, which was negative 16, or the y component, which was negative 16t squared plus 180 sine of 22.5t, and then plus 3. Now, if we were going to go ahead and graph this, come on, why would it not show me? You can see that there is the graph. That is like the path of the ball with respect to time, right? So you have the x and the y components, but then we can also kind of figure out time. Obviously, we can kind of create a slider here, and I'm not sure why I'm having issues with this. Now, I accidentally did x equals 400, so let's look at that. Okay, so at x equals 400, here's like the wall. Now again, remember, at x equals 400, the wall was only, we said 20 feet, right? So obviously, you can see that we are clearing it. Remember, I got like 73, somewhere around there. So, I mean, it looks like maybe, I don't know, it looks like could have been a little off. But either way, if the wall is only 20, it obviously cleared the wall, right? Now, my real problem was at 20, or at 420, but you can see it doesn't really matter. The wall, if it's only 20 feet, this ball is definitely clearing that wall. So here's a graphical approach. I showed my students how to type this into their graphical using parametric equations, but I also just showed you don't have to use a graphing calculator to be able to determine those parts of, to determine like solving those. All right, so let's go back to notability. There we go. I don't like that. All right, so now before I get to the multiple choice, and I'm not sure, that was so annoying. So before I get to the toggle source. All right, multiple choice, I will go ahead and check in, see how you guys do. Rosa said, does he read his comments? Yes, I do read my comments, but you kind of joined a little bit late. So, or at least on my live streams, I like to kind of work through the math, and then I kind of take a break here at the lesson. So Jonathan K, hey, how are you? Hussein, maybe, yes. Drake C, yes, I do, and happy to be able to answer any questions that you guys have. If you do have some requests, I can maybe write them down, and we'll see how much time I have. Let's see, it's 9 or almost 10 o'clock, so cool. Young solo math is not my strongest area. Well, I'm glad you are here. Hopefully this is the right place for you, and hopefully some of my live streams, the ones, obviously I've been doing recently or in the past. Obviously, I think I have the playlist on my description that you can go and follow and see all my past live streams. Hopefully those can help you out, kind of go through some examples and at least a little bit of explanation. I need help with the convulsion. I'm not sure. That's not something, Saad, that I go through in the class, so I'm not really sure what I would what I'd be able to do for you for that. So I'm a second semester senior, no longer care about doing my math homework, but I just wanted to say thank you for getting me through Algebra 2. You are very, very welcome. Very happy for you to get by. And again, just I wish you the very best with math or without math. Obviously, I always say, students even if you've had a bad experience in math in high school or in college, don't ever let that hold you back. Because if you ever want to pursue anything that includes mathematics, where else, you can do it. It takes some work, it takes some effort, right? It takes some repetition. But I've seen so many students that they get frustrated because they get a math class or they get a math teacher and they struggle and they just feel like it's the easiest thing to do is give up or to accept the idea that, oh, they're not a math person or they can't do it. And, I'll just do something that doesn't relate to mathematics. And, I think that really gives you a big disservice, later on in life. And because I don't believe there are math people, non-math people, obviously you're going to have tough times. Obviously there's going to be classes, there's going to be teachers, there's going to be situations where learning the math is going to be more difficult than other times. And sometimes it's just maturity. You just need more time or it's not the right environment or it's not the right timing, but don't just give up and say you can't do it because I don't think that is going to be the case. And I'm not saying that's what you were, doing, but it just kind of triggered me a little bit to want to add some things for you guys. So hopefully that maybe helps some of you guys out. 420. Yes, I know. Thank you guys. I'm so sorry. Look at the Sean here, Go Gamer. Yeah, I got to work on some of my merch. I don't know. It's I'm just so busy working on some of the stuff. Chris Crum asked if I can do their homework. No, I can't do your homework. I got more stuff I got to do my own. Any help on graphing quadratics? Con, if you can let me know whatever quadratics you have, please feel free to let me know. Enrico is asking about geometric series. It has been way too long. I don't have the formulas available to me right in front of me, so I'm sorry. That's just not something I'm gonna feel comfortable kind of working out on a live stream for you. Yeah, sorry, Rika. We don't teach geometric series anymore in the pre-calculus, so it's been a couple of years since I've taught it. So, kind of going through, I don't have the sum formulas. I don't have a textbook with me. So, being able to pull up all the formulas and stuff like that. But that's basically what you're going to want to do when working with series is just really kind of apply the formulas, find your, obviously if it's geometric, finding your R, finding your, a sub 1 usually, I believe, if I remember correctly, and going from there. All right. Can you solve x plus y? All right, another systems of equations. So I'll probably go ahead and do this. So I got a request from Marcus. X plus y equals 2. And then x is equal to 2y plus 2. All right. Just kind of seeing if there is any other questions, at least back in there. Doesn't look so. Whoa. Rika, sequences, we used to teach it. We used to teach sequences and series as a part of pre-calculus. They just took it out of our curriculum. So, in the last 4 years, I haven't taught it. So I just, like I said, that's not a part of our curriculum. It is typically a part of curriculum, and personally, I believe it should be a part of a pre-calculus curriculum. And I don't know why our curriculum does not include it anymore, but I have to unfortunately follow our curriculum to prepare my students for our district and, stuff test. And obviously, as far as calculus goes, most students you're not going to get into sequences series until Calc 2. So I'm not sure why they took it out for that case, but it is typically a part of a pre-calculus curriculum, though. Well, so happy to be able to help you out, Maddie. And Paul, you basically are in my class. I mean, everything that I go over on here, you guys basically kind of get, with a lot of my homework. So hopefully that is kind kind of makes you a little feel like you're in my class, because this is the real homework that I give my students and the real quizzes that I give them that I go over. So obviously checking in all the live streams, you're getting a lot of the instruction that my students are getting, or at least the way that I teach is the same. All right, well, before I get into that stuff, guys, let's go ahead and just do some more eliminating the parameter problems. Again, in this case, if I wanted to solve for this one, you guys can see in this case, this isn't that bad because t is already solved. So why don't we just plug t in into the y equation? So therefore I have y is equal to negative 5 times 6x minus 6. And now you can just apply distributive property. Negative 30x plus 30. That didn't work. Minus 6. 6x minus 6. Oh, plus 10. Okay, so it's negative 30x, and then that's going to be 40, which is answer C. Next one again is eliminate the parameter. So to solve for t in the x equation in this case, I can get t is equal to x over 3. So therefore y is equal to x over 3 plus 7, which is answer D. In this case, that's again kind of the same one that we talked about for the ellipse. So therefore, I kind of have x squared. So remember, it's cosine squared plus sine squared equals 1. So you're basically solving for sine squared and cosine squared. So that would be y over 4 squared. And then when you go ahead and simplify that, that's x squared plus y squared over 16 equals 1. Now, this one is kind of a little confusing at first because you're like, no, this doesn't match up, right? But again, if I have 16 in my denominator, if I multiply everything times 16, I'm going to get a 16x squared plus y squared is equal to 16. So this kind of comes into one of those like manipulation problems, like you need to manipulate the problem to kind of get what you want, which in this case you can see the answer is B. All right, last one. This one's kind of the same one. We kind of already did this as well, so hopefully students were not so freaking out here. To solve for t, you get x squared, and then you can plug that into the other equation, 2x squared plus 5. And so we have 2x squared plus 5, and therefore we can see is C. So there you go. Nathan, what's up, my man? Glad to have you on here. I don't know what means. Well, hopefully I know you, I think you maybe missed last class, so maybe this is a good live stream to go and check in, but glad to have you in. Do you have a schedule for live streams, or is it whenever you want? It's basically whenever I want. Rish, I tried to do my best. I'll let you know this week. I will be going live Monday and Wednesday. So that is just kind of my schedule for this week. I try to do Tuesday and Thursday, but it really does all kind of depend on when I assign my homework and we have quizzes for my class and my classes. So I try to schedule them at least a couple hours before. Today I kind of was a busy day for me, so I wasn't able to do that. But I try to at least try to do them at least in advance, and it's usually going to be twice a week, or maybe there'll only be one stream a week. But obviously, if you're subscribed or have notifications, you'll be obviously alerted in there when I go live. How your past videos help you out? Well, very happy to help you out, Zimmerman. How do you do slopes? Well, AWAG, let me know what you mean by how do you do slopes, like graphing, writing, solving, like identifying the slope. There's a lot of different things I could talk about with slopes. So if you give me a little bit more information, I'll be happy to explain a little bit more. If you handle Calculus 1, mostly the application sector, or watching from Kenya. Bryn, I would love to be doing calculus. Unfortunately, this year I am only teaching pre-calculus, so maybe that will be something next year. So I apologize, that's probably not going to do much for you this year. I did teach calculus for the last 2 years, so if you go in my playlist section, though, you can see there are some videos that cover calculus from there. Rich, can you do some vertical, horizontal, and slant asymptote examples, finding x and y intercepts? Sure. So we can do VA, HA, SA, X and Y intercept. Now that is kind of a lot, so I'm probably just going to do like one example of, I'll try to do like 2 examples and then cover both of those from there. Because I don't want to take up too much time, because I'm also going to... Jonathan K says, how do you handle being a YouTuber? Well, I don't consider myself a YouTuber. I've been a teacher. I mean, I have been doing YouTube videos for... Geez, I don't know. I can't remember my channel. I think 2012, maybe 2000. Yeah, 2012, I think. That's how long I've been doing YouTube videos. And then, yeah, I've been a teacher since 2007. So, you know, one of the things that it just kind of helped me out. Obviously, I record a lot, so that kind of helps me out. And you guys noticed, if you guys watch my videos, there's not a lot of polish to it. There's not a lot of things to it. It's really just me teaching my class and me recording it and allowing you guys to kind of watch into there. I keep on trying to do a little bit more where it's more just direct to me helping, you know, talking to you guys out on YouTube. But, you know, that takes so much time, and it is very difficult to be a teacher, to be a father, a husband, and all those other things. Like, it's just, there's not enough time to be able to focus. So, you know, almost all of my 11,000 videos are just of me teaching, just little snippets of me teaching. This year, you know, I've basically been live covering all of my homeworks and quizzes, going over them for my students, and that has been very helpful. It's nice to have a wife that is very understanding and supportive of your, you know, kind of goal to help students with their mathematics. So, you know, that's kind of nice just to give me that time. And then also, you know, what I'm looking into, a lot of the stuff I'm creating now, which takes a lot of time to create all of this content. But I'm hoping, obviously, if I teach pre-calculus next year, which I assume I will, then I'll have a lot of the stuff already created, right? I won't need to go live every single night for my homework assignments. Like, obviously, I'm going to adjust these homework assignments and like improve upon them, but I'm not going to spend as much time as I'm doing now recreating every assignment. For quizzes and tests, that's a little bit different. I will, but you know, for the homework assignments and stuff, I'll just probably add to them to make them better. All right. You solving rational equations. Okay, well, I can kind of get into that as far as like the x and y intercepts for you. I'm assuming that's, you know, I'm not, unless you have like a solving rational equations problem, I'm not going to be able to get through, you know, all of that. And quick graphs using intercepts. What do you mean, graphing like linear equations? Like, I mean, there's a lot of different ways, but I could just, wait, would you ask that same? How do you solve? Okay, quick graphs using intercepts. All right, so I can do that. Graph using intercept method. All right. Zuma says, I'm struggling with algebra. Any tips or suggestions? I mean, it's, you know, the thing is, I don't know what you're struggling exactly with. I mean, the main thing I would say is, one, you know, make sure you can try to get with somebody that you can practice. I mean, there's 2 things you really need. You know, one is just a lot of, you know, usually practice. You're probably struggling because you're having a hard time conceptually understanding the material. And then also you probably have some prior skills that you're a little bit, you know, weaker on. So you need to be, one, refining those skills, and that's going to help you conceptually understand the content you're working on. And I also think it's just helpful to be able to work with somebody that you can ask questions on. You know, when you don't understand math, a lot of people feel embarrassed because, especially if somebody next to them understands it and they don't, and you're like, you know, I don't want to ask the question because then I'm going to feel stupid. So you got to find somebody that you can feel stupid with, because that is going to be very important. Then you can ask those stupid questions. Be like, why is it this? And then they'll tell you, and you're like, oh, I'm stupid. But then you're like, but now I get it. Like, now it makes sense to me, right? And a lot of students, I think, are just afraid to ask those questions because they don't want to feel stupid, right? And they have a legitimate question. It is a good question, but they just feel like they're going to look stupid because the person next to them maybe knows what they're doing. So they just like kind of sit there and say, oh, I'm just going to do this all by myself, or pretend I'm doing it. I understand what I'm doing. So I would just, you know, ask questions and practice. Those are like 2 very basic things I can tell you. All right. Does it show that you gave me a rational? Well, that was a different. Is that your same one? Oh, okay. I don't know if was that the same equation? Graph intercepts. Somebody asked for rational equations. I can't remember. I'm a 6 or 8, and I have to do one-step inequalities. Well, you can definitely do one-step inequalities. I have some videos on that. I'm not going to, if you have one that you want me to kind of do, I can probably cover it for you. But that is, but please make sure you just kind of type it in there, and I'll be happy to solve rational equations. Okay, so cool. Yeah, did you ask that? All right, so I'll do this. All right, guys, I am going to close the question requests. Unless we have like a one-step inequality. I don't know, x equals 12, what you're asking me to do, Z Drakey, if you want me to graph that or what. Oh, you're very welcome. Juleski? Juleski? Awesome. Jules, I like that name. And then Ski. Cool. Well, you're very welcome. Very happy to be able to help you out all the way in Penn State. All right, so I'm going to do 1, 2, 3, 4 types of problems. I was something word problems for 1 and 2-step equalities. Those can be it, and I know a word problem G7 is the can be difficult. I do have some examples. If you look at one step and stuff like that, you can definitely go ahead and I have definitely some examples on them, but it's probably not something, I'm kind of at the end here. I'm going to have to wrap this up. So I know those problems are a little bit more difficult to be able to cover, at least for right now. And Z Drake said, I don't understand what the question is, x equals 12. So I'm not sure, what are you asking me to do? Graph it or find the value of x, which would be 12. Well, I'm sorry to hear about that, Sam, but I'm very happy to help you out. So thanks for joining in. Okay, so yes, G7, take a look at those videos, and then otherwise message me if you have trouble, if they're not making sense. But guys, what is 2 plus 2? It is 4. I am ending the chat. I'm sorry, guys, if you type in a question. I need to get these over, and then I need to get prepared for my next class period, which is tomorrow. But I still got to fine-tune some things. So let's do first one, question number 1, systems. So again, guys, when we're solving a system of equations, we're looking into finding the value of x and the value of y that makes the equation true. Now, typically, when using solving a system of equations, what we're doing is we're looking for a variable that is either isolated or has a coefficient of 1, and then we'll apply the substitution method. So you can see here that we have a variable x, which is isolated. X is equal to 2y plus 2. So let me do this again. So x is equal to 2y plus 2, right? That means the value of x is equal to 2y plus 2. So what I can do is I can plug in the value of x into the other equation. So I can write this as 2y plus 2 plus y equals 2. So basically all I did was I plugged what x is equal to into the top equation. So I restated the question, restated the top equation, and I plugged what x represented in here. Now I just need to go ahead and do some math to simplify this. So therefore I get 3y, plus 2 is equal to 2. Then you subtract a 2 on both sides, and you get 3y is equal to 0. Divide by 3, y is equal to 0. So we know that y is equal to 0. And now, if I want to figure out what x is, I just type in 0 in for the y. So now I'm plugging it into the other equation. And that's what, plus 2? So therefore, x is equal to 2. So therefore, when x is equal to 2 and y is equal to 0, that makes both of these equations true. If you're looking at the graphical approach, that's where those two graphs are going to intersect each other. So that is the solution. Sometimes we write them as a solution point, 2, 0. Next one, step number 2, solving rational, well, it's really just solving an equation with fractions, solving a linear equation with fractions. So the main important thing I like to do here is just get rid of my fractions. So I noticed that the LCD of all of my denominators, 3 and 2, is 6. So the least common denominator is equal to 6. So if I multiply everything times 6, what's nice about multiplying by the LCD is that all of my denominators are going to divide into 6. So plus 6 6 times x over 2 is equal to 6 times 10. Okay, so now what you guys can see is, well, 6 divided by 3 is 2. 6 divided by 2 is 3. And then that becomes 60. So now I'm left with a 2x plus 3x is equal to 60. Therefore, that equals 5x equals 60. Divided by 5, divided by 5, x is equal to 12. And that is your solution. So you didn't do it that way. You could have got common denominators and combined them. But my point is I usually like to just get rid of fractions. Let's do graphing intercept method, and then I will end with vertical, horizontal, and slant asymptotes. For those of you guys that are kind of joining in, I do apologize. I am kind of out of time, so I'm not going to be able to get to any more questions. I'm going to answer these 2 questions here, and then I'm going to have to head out. So question number 3, graph using the intercept method. So I don't have an equation here, so I'm just going to show a process. So y equals, if we had something like this, 3x minus 4, that is what we call in slope-intercept method. So slope-intercept method, if you remember, that is easiest to graph using the slope and the y-intercept. And then you just, plot the y-intercept and then use the slope to find another point, and then you can connect. Now, the other one that's a little bit more difficult is standard form. So for standard form, that is typically when we have like the x and the y. Like, let's see, 4y is equal to 8. So there we have the x and the y on the same side, right? And they have some coefficients. Now, here it's not in slope-intercept form. So there's 2 ways you could do this. You could, and this is actually a good segue into our rational expressions. If I had to graph, actually, let's just graph both of these. So negative 4 is 1, 2, 3, 4. So that is the y-intercept. And then you go up 3, 1, 2, 3 over 1. Or you could go down 3, 1, 2, 3 to the left 1. Either way, you can see how that creates that line there. Okay, so that's that equation. And again, I'm just making these up because I didn't have any problem to go off of. Now this equation, you could rewrite this in slope-intercept form to figure out what it is, right? So you could solve for y. But many students looking at it, they'll be like, that doesn't look that fun. So the other way we can do this is find the x-intercept. Now the x-intercept is when y is equal to 0, right? If you look at like where this graph crosses the x-axis, that's when y is equal to 0. So then all I'm going to simply do is just plug a 0 in for the y. And therefore I get a 2x is equal to 8. Therefore x is equal to 4. So now to find the y-intercept, x is equal to 0. So now I'm just going to plug a 0 in for the x. And then now solve for y, which is a negative 2. So now I have the x-intercept and I have the y-intercept. So to graph this equation, all I'm simply going to do is plot the x-intercept, 1, 2, 3, 4, and plot the y-intercept, 1, 2. And now you can just connect those 2 points, and then you have an equation of line. So if you want some quick way to graph an equation of line, and you don't like graphing slope-intercept form, using the intercept method to graph is usually very helpful. All right, the last thing is, again, just for the sake of time, I'm not going to spend too much time like explaining everything, but I will talk about the vertical, the horizontal, and the slant asymptotes. At least doing, well, crap, I'm not going to be able to do an exam. I don't know. We'll see. All right, so, just remember horizontal asymptotes. That is when, just a quick little, actually not horizontal asymptotes. Let's do vertical asymptotes. Vertical asymptote. Just remember that is going to be when you have, when your denominator is equal to 0. Like, so for instance, if I had this equation, your vertical asymptote is just your denominator set equal to 0. So your asymptote occurs at negative 1. Now, if you need to find the x and the y-intercept, the x-intercept is just what we did when y equals 0. So you plug 0 equal x minus 5 over x plus 1. Now, when you multiply by x plus 1 on both sides, you get 0 equals x minus 5. So the nice thing about this, which I remember going over in my class, is when you're trying to find the x-intercept, you basically just set the numerator equal to 0. when you're trying to find the y-intercept, that is when x is equal to 0. So you're just plugging in 0 in for x. Right? And therefore, basically, you notice that this is going to be a constant over the constant because you're plugging 0 in for x. So the horizontal asymptote, you're just setting the numerator equal to 0. X and y intercepts, you're plugging y for 0, solve, and then plugging x equals 0. So the exact same thing we did for a linear equation. Horizontal asymptote, there's basically two things we're looking at. I'm not going to go through all of them. I'm just going to kind of do an example here. So let's do, if we had x squared minus 5 over, x plus 1. Let's do y is equal to x squared minus 5 divided by 3x plus 1. And then let's do y equals x minus 5 divided by 3x squared plus 1. So notice when the degree is larger in the numerator, so 2, so when 2 is greater than 1, so the degree in the numerator is larger than the degree in the denominator, there is no horizontal asymptote. When, no, that's wrong. What is that? Oh, those are supposed to be the same. My bad, I forgot to write it in there. So when they are equal to one another, so we can say 2 is equal to 2, then your horizontal asymptote is the leading coefficient over the leading coefficient, which is, in this case, 1 over 3. And then when the numerator, the power in the numerator is less than the degree in the numerator is less than the degree in the denominator, then your horizontal asymptote is y is equal to 0. So the only time that there is going to be a slant asymptote is when there's no horizontal asymptote. Now again, there could be a hole, so there could not be a horizontal asymptote at all. Or if there is a slant asymptote, all you're simply going to need to do is apply long division. So let's go ahead and do this equation again. So we have x squared minus 5 divided by x plus 1. So to find the slant asymptote, I'm basically just going to divide my denominator into my numerator. So again, to go through this, x goes into x squared, x times x. Make sure you multiply by both terms of your divisor. X times x is x squared. X times 1 is x. Now, positive x. Now, I don't have anything to subtract my x from, so what I'm going to do is just create a little bit more room here. Let's go back to 0. So let's put a plus a 0x minus 5. Okay, because 0x is going to be basically my placeholder. So now I subtract my rows, so therefore that gives me 0x. 0x minus x is a negative x. And then negative 5 minus obviously nothing, it's just going to be negative 5. Now x divides into negative x, negative 1 times x is a negative x. Negative 1 times 1 is negative 1. Now it doesn't matter here if there is a remainder or not. That is not really the issue that we're looking at for long division, or for the slant asymptote. Here we're going to get 0 again, and then negative 5 minus a negative 1 is going to be a negative 4. So anyways, that is your remainder, but we don't really care about the remainder. I'm not going to get into that now, but therefore our slant asymptote is basically just going to be y equals the quotient without the regard of the remainder. So there you go, ladies and gentlemen. I actually covered that a lot faster than I thought to. Hopefully that was helpful for all of you guys, especially those of you that had some homework questions. Good job with the homework questions. This is one of the best homework questions I had from you guys. You guys had a lot of good stuff in there. So very welcome to you guys. And then Pointless, what's up? How you doing? And then, but unfortunately, guys, I'm going to have to go for the rest of this stream. But hopefully, for those of you checking on the replay, this was helpful for you. And then now I am going to let you know, though, I will be going live again on Wednesday. And then if you guys want a copy of this again, I'll have a link, obviously, in my YouTube membership for those of you that are interested in that as well for that. So otherwise, peace out. Oh, just about.